Each Beriev A-50 airborne early warning aircraft is estimated to cost roughly $350 million to build. These long-range radar planes form a core element of Russia's ability to detect and track threats across vast distances. Over the past 2 years, Ukraine has sharply degraded this capability, creating coverage gaps and forcing many remaining A-50s to operate with reduced effectiveness. The strikes have eroded Russia's ability to see and control the skies along critical sectors of the front. To understand how this happened, we need to look at the A-50 itself, its role, its weaknesses, and how Ukraine exploited them. How Ukraine turned Russia's skies blind. The Beriev A-50 NATO codename Mainstay is Russia's airborne warning and control system, or AWACS. It forms the centerpiece of the country's long-range aerial surveillance strategy, detecting and tracking aircraft, missiles, and drones, and feeding vital data to fighter pilots, ground-based air defenses, and command centers. Over Ukraine's 700-mile front, its real-time tracking capability has been a critical tool for coordinating operations and maintaining situational awareness across dispersed Russian forces. But the strengths that made it indispensable have also made it a high-value Ukrainian target. Built on a Soviet-era airframe introduced in the 1980s, the A-50 combines aging electronics with a small, irreplaceable fleet. Estimates vary. After the February 2024 shootdown, Ukraine's intelligence chief Kirilo Budanov assessed that 6 remained. Other analysts put the maximum at 7, and some sources claim only 2 or 3 are truly flyable. Maintaining the rotation needed for continuous coverage requires several airframes in active service at once. 1 on patrol, 1 returning or preparing, and 1 undergoing maintenance. The aircraft's large, distinctive radar dome also makes it conspicuous and practical to target when stationary, especially with precision strikes or drones. These combined factors, age, limited numbers, and visibility, created openings Ukraine learned to exploit. Aware of the A-50's role in orchestrating missile defense and fighter interception, Ukraine began by testing electronic warfare. By jamming or spoofing GPS and communications links, it was able to cause momentary lapses in coverage, forcing delays and misidentifications in Russian threat tracking. RUSI assessments suggested that even short-lived disruptions left A-50 crews effectively blind at key moments. As the war progressed, however, Ukraine moved from degrading capability to destroying aircraft outright. The first significant blow came in February 2023, when an A-50 at a Belarusian airfield was damaged in an attack. The strike neutralized the aircraft from operations and showed Ukraine could hit high-value surveillance platforms even hundreds of kilometers from the front. In January 2024, another A-50 was destroyed over the Sea of Azov. Reports suggest a Patriot missile may have played a role. Just weeks later, in February, a joint mission by Ukraine's main intelligence directorate and Air Force downed an upgraded A-50U in the same region, this time using a Soviet-era S-200 surface-to-air system adapted for the task. These kills were hard-earned. A-50s normally orbit well behind front lines and are guarded by layered defenses, including S-400 missile batteries and fighter escorts. Yet each successful strike amplified the pressure on Russia's surveillance network. With fewer aircraft to rotate, sortie patterns became sporadic, leaving exploitable gaps in radar coverage. Ukrainian ground forces could maneuver without constant tracking. Air defenses struggled to position themselves effectively. Offensive Russian air operations slowed as pilots lost the safety net of persistent early warning. By mid-2024, this erosion of capability reached a critical stage. With their A-50 fleet dwindling, Russian commanders had to decide where to station the remaining assets. Concentrating them over one sector left others uncovered. Spreading them thin weakened all sectors. This forced trade-off not only reduced Russia's situational awareness, but made every surviving aircraft a more tempting target. Ukraine's strikes were no longer merely attrition. They actively reshaped Russian decision-making. In June 2024, Ukraine escalated its campaign in a way that directly targeted these last remaining aircraft inside Russian territory. That phase would prove to be the most audacious yet, blending unconventional delivery methods with precision targeting and striking at the very heart of Russia's airborne surveillance assets. What followed was a demonstration that even heavily protected systems could be reached and damaged by unorthodox means. Operation Spiderweb, a game-changing tactic. Operation Spiderweb marked one of the most inventive uses of asymmetric tactics in the conflict. Ukraine conceived a way to move large numbers of small drones deep into Russian-held territory without triggering the defensive systems in place. By blending into routine civilian logistics, ordinary-looking vehicles transported the drones close to high-value air bases. Once inside prepared staging areas, Ukrainian operators coordinated precision swarms that could launch from within Russia's own perimeter, exploiting surprise and overwhelming fixed defenses. The drones employed in these strikes were relatively simple compared to traditional aircraft, but they were guided with clear targeting priorities. Their primary objectives included the radar domes of A-50 surveillance planes, critical for airborne early warning, along with runways and key installations around the airfields. Damaging the radome of an A-50 struck at the core of its purpose, degrading its ability to provide real-time intelligence to Russian forces. Secondary strikes on parked aircraft and base infrastructure added to the disruption and forced repair efforts. By striking from close range, the drones avoided many of the detection and interception measures designed against incoming threats from outside Russian-controlled airspace. Coordinated launch timings meant swarms arrived in overlapping waves, stretching defensive reactions and making it difficult for responders to predict where to focus. Weather conditions masked some of the attack profiles, reducing visibility and further undermining Russia's response. Analysts later assessed that Operation Spiderweb reportedly hit the radar domes of 2 A-50s during the assault. While early reports claimed dozens of bombers were destroyed, figures that were soon questioned. The confirmed damage to these scarce surveillance assets was the most strategically significant outcome. This further reduction in Russia's A-50 fleet forced immediate operational adjustments. Surveillance coverage had to be thinned and repositioned, leaving sections of the front less monitored. Every redeployment carried a trade-off, with coverage gaps appearing as airframes were shifted to guard only the most critical sectors. In practice, this limited the ability to maintain consistent intelligence across the entire 700-mile front, creating opportunities for Ukraine to exploit in subsequent operations. The high-impact nature of Spiderweb lay not in the material cost of the drones, but in the cost of what they disabled. Each A-50 was an expensive, difficult-to-replace platform. Striking them inside protected zones demonstrated that high-value hardware could be neutralized through low-cost, unconventional means. It also exposed weaknesses in security protocols around critical assets, revealing that Russia's layered air defenses were not designed to handle attacks launched from within their own territory. Beyond the specific damage inflicted, the operation illustrated a broader trend in modern warfare. Hybrid and low-cost tools, when used with careful planning and strategic coordination, can create disproportionate effects. The loss of 2 operational A-50s in quick succession degraded one of Russia's most important force-multiplying capabilities and showed that even without access to comparable technology, an adversary can reshape the balance by selectively targeting enablers rather than attempting to destroy all frontline assets. From that point forward, the question for Russian planners was not just how to defend against future incursions like Spiderweb, but how to recover the capacity already lost. With sanctions constraining access to components and the production of new A-50s dependent on specialized facilities, replacing these aircraft posed a problem measured in years, not weeks. And while damaged airframes could, in theory, be repaired, each loss during active conflict imposed strategic consequences long before any replacement could enter service. This left Russian commanders facing increasingly difficult choices about where and how often they could maintain eyes in the sky. The cost of losing eyes in the sky. Replacing these specialized aircraft is not simply a question of budget. It is a problem compounded by infrastructure loss and international isolation. The December 2024 Ukrainian strike on the aviation scientific and technical complex in Taganrog, Russia's only facility capable of building and repairing A-50s, inflicted severe damage on the plant's production halls and disrupted its workforce. Combined with export sanctions cutting off access to critical radar, avionics, and electronic components, it makes near-term replacement or repair of these aircraft highly unlikely and slow to recover. What was once a question of manufacturing timelines is now a multi-year rebuilding challenge, tied directly to the tempo and outcome of the war. The scale of the investment at stake is significant. Each A-50 is valued at roughly $350 million, and that figure excludes the additional costs of integrating it into operations, training new crews, and maintaining it over decades of service. Sanctions have also choked the supply chain for key subsystems, from large radar arrays to smaller items such as processors and wiring harnesses sourced abroad before the war. Without these parts, even minor repairs can be delayed indefinitely, degrading the readiness of the remaining fleet. The destruction at Taganrog means there is currently no alternative domestic pathway to fully restore damaged aircraft, further deepening the gap left by each loss. This fleet deficit directly undermines Russia's intelligence, surveillance, and reconnaissance posture. To sustain continuous early warning coverage across the 700-mile front line, analysts estimate that Russia needs 3 separate patrol orbits, each supported by a rotation of 3 A-50s. That means roughly 9 operational airframes are required at one time, not counting reserves for maintenance or downtime. Current estimates suggest Russia has far fewer. Some assessments put the number at 6 or fewer functional aircraft. This shortfall forces planners to accept coverage gaps that would have been unacceptable in the war's early stages. With inadequate numbers to cover all sectors, Russian commanders must make hard operational choices. A surveillance focus on the north, for example, to support an offensive push toward Sumy, can leave the Donetsk axis without dedicated airborne early warning. Conversely, reinforcing coverage over the east risks leaving southern approaches less monitored, creating space for Ukrainian counterattacks. Each decision carries consequences on the ground, as forces operating without ISR support face greater exposure to surprise strikes, reduced coordination with air defenses, and slower reaction times. The effect is most visible where these gaps align with Ukrainian operational priorities. Intelligence lapses can allow Ukrainian drones to penetrate deeper before detection, their flight paths untracked, until they are within striking distance of depots, airfields, or command centers. Absent timely aerial tracking, Russian ground units lose the synchronization that links fighters, surface-to-air missile batteries, and artillery, reducing the cohesion of layered defense networks. In environments where speed of response determines whether a missile is intercepted or a convoy is dispersed before attack, even short disruptions in coverage can have outsized consequences. The vulnerability extends beyond individual battles. By degrading and constraining the A-50 network, Ukraine has steadily reshaped the strategic rhythm of Russian operations. The strike on Taganrog did not make new production impossible forever, but it has created a structural barrier that is unlikely to be overcome quickly enough to restore full coverage during the current conflict. Every destroyed or damaged aircraft pushes that timeline further, locking in an imbalance that gives Ukraine greater freedom to plan and execute operations without constant surveillance overhead. For Russia, the loss is measured not only in high-value aircraft removed from service, but in the erosion of a system that underpins both defensive and offensive action. Without the continuous eyes in the sky the A-50 fleet once provided, its forces must operate under greater uncertainty, accept higher risks, and cede initiative in sectors where coverage cannot be maintained. This degradation is cumulative, and while individual attacks on the fleet may look small in scale, together they have strategic weight far beyond the immediate damage. The result is a conflict environment where success hinges as much on disabling critical capabilities as it does on destroying them outright, a reality that will shape both sides' priorities going forward, and one that carries implications far beyond this war. Ukraine's layered campaign, combining electronic warfare, missile strikes, drone swarms, and strikes on repair infrastructure, has created sustained and systemic degradation of Russia's airborne early warning capability. By steadily eroding the operational availability of A-50 aircraft, it has forced Russian commanders into a constant trade-off between coverage priorities and vulnerability, weakening their ability to coordinate air defense and frontline operations. If Ukraine maintains pressure on these assets and the Taganrog repair line remains offline, Russia will struggle to restore full airborne surveillance for the foreseeable future, with direct implications for how battles are fought. If this breakdown in Russian air surveillance matters to you, subscribe for evidence-based analysis and comment on which piece of proof surprised you most.